Good morning, everyone.
Good morning.
Yeah, hi, Musa. How are you? You are muted if you are saying.
Oh, yeah, yes. How are you, Johns?
I'm fine. How are you?
Good, good.
Yeah.
Good morning, John.
Hi, Kwesi. How are you?
Not bad. Good. It's Musa. How are you, Musa?
Good, and you?
Good. Going to get something to munch on quickly and just come back.
I know.
All right. Have a good one.
Good.
Yeah, so let's wait another minute and then we can start as others join.
Okay.
Okay, so good day, everyone, and welcome to VADSTI for 2022. If today is your first time joining us, my name is John Kwejan. I'm a professor at Howard and director of this program. So again, as we've said, yesterday we started this program last week, and the first 3 weeks is what we call the pre-training sections. So the pre-training sections are recordings from the spring series. We had a spring series in February and March. So this series recordings are discussed or facilitated by faculty on this program. So Dr. Dumbia actually taught Python 1 and 2 in the spring. So that was covered over 2 weeks. Now you are having this for only 1 week. Again, the recordings are there. Take your time, review both Python 1 and Python 2. And then if you have any questions, you can send email to Dr. Dumbia or Dr. Ibel in WAFO, and then they will respond to your questions. So without any further ado, I will hand over to Dr. Dumbia to continue with this training.
Thank you, John. Welcome, everybody. Like John mentioned yesterday, I still want to share our Coursera course with you before I start anything. This is what it will look like. There are two of us, Denise and I, create this course. It's free. If you complete the capstone projects, you do all the assignment, you will get a certificate at the end of the program. So it's 100% free. So please feel free to take this course. Okay. So Today, we're gonna share a video with you where you will learn more about sets, list, input, if else statement, list comprehension functions, and if we got time, we might do some Panda data frame as well. So let me share that video with you. Can you hear? In addition to set, we also have something called next thing the first thing that I want to mention today is set, right? So like dictionary set will be within the curly brackets, but it doesn't take a repetition, right? For example, let me define a list that have a repeating numbers in there, and I'll apply set to it. The set method, you will see that it will take care of it will remove the repetition, right? So they have to be between curly brackets. So let me say, I say new list equal, for example, 1 1 2 3 3 4 4 4, for example. Right. So I have this. Good morning. So I have this list. One comma is missing. Yeah, double extra comma. So now, if I use the set to this, so SAT new list, right? New list. It just give me 1 2 3 4. So it doesn't accept the repetition, right? So you can also build a set of tuple. You have a tuple, then you can set of that. Then you have it. You can also manually build it directly. Your a set equal these, right? 1 2 3 4, right? So people use set method if they want to remove a repetition, right? And then if you run it, it's a set, right? So you can build it of tuples, right? Like I said, you can set, let me say tuple set equal, I would say SAT, and then here I will have a tuple is inside her, right? So tuple should be between parentheses, then 1 3 5, for example, right? And then let me see what the tuple set look like. Right, so give me a set, right? So in addition to sets, we also have something called, since I just mentioned, let's go to tuple. So tuple are unmutable. These are unmutable. Right? You cannot unmutable. So you cannot update the value. For example, if I have my tuple equal, for example, 1 2 3 4 5, right? I can unpack this tuple for my tuple, for example. I can unpack it, I can access an element in this thing, but I cannot update an element in this tuple, right? For example, I can unpack it with how many number I have, 5 elements. So I can say A, B, C, actually, A, B, C, D, E. I can say that this is equal to my tuple here. So this means A will be as 1 will be assigned to A. So this number must match. I have 5 here and I have 5 here, right? My tuple Y is missing, right? So if you run A, for example, A would be, oh, I've got A twice. So A, B, C, D, E, right? So, right, A equal 1. If you say D, for example, D would be 4, right? But if I'm trying to adjust one of these, to update one of these value here, then I will get error message, right? For example, if I say my tuple, the first value, if I say my tuple, let's say I will assign the first value to, instead of 1, I want to say that is equal to 7, for example, right? Tuple, doesn't support item assignment, right? Okay, any questions so far? So let me look at the chat. I'm also here. Okay, good. Right, so tuple set, now we can talk about some basic operations. Right, yesterday we were dealing with a Boolean, so Boolean will require some logical operations. You're comparing different statements, so basic operation. So for example, in the Boolean, yesterday we were comparing two numbers, right? So for example, if I have a 1 less than 0, right? So this is it will return true if it is, right? This is a Boolean operation here. If 1 is less than 0, it will return false if it's not, right? So 1 is not less than 0. But if you combine this, right? Usually if you want to combine more than one operation, use parentheses. So if I say 1 is less than 0, or here I will use parentheses again, or let's say 12 is bigger than 5, right? So it will go through this. This is false. I only need one of them to be true. So because 12 is bigger than 5, then this will return true, right? And then this operation also, let's say C here, capital C equal C lowercase c. Python will return false for this because it's a case sensitive, right? But if I combine these n to another logical operation, so for example, I have 20 is bigger or equal to 5, for example, right? Or let's say 20, for example, right? So because of n, both of them need to be true, right? Even if this is true, but this is false, this will return false, right? So the next thing that I want to talk about, since you will have a lot of opportunity to go through these type of problem during the lab. So I want to start there and go to if-else statement. So if, else, elif, right? Elif statement. Okay, so I want this to be a markdown cell, right? So for example, I will say if statement, so if some condition is true, do this, right? I don't have to return. So for example, I can say if hungry, feed me, or if let me start with if true equal false, for example, right? Then I want to print if that is true. If this condition is satisfied, I want to say yep, that is. So that's if statement. So if it is false, then nothing will print. If it's true, we'll print something here, right? So instead of that, you can have this is the case when this never print. Let me look at this message. Okay. So I can change the condition, right? If 2 is less than 2 less or equal to 5, print, yep, right, and that's it. So we check a condition. If that condition is satisfied, do something, right? So it becomes interesting when you add else, right? And elif, it becomes, because you will be adding more conditions. So if this condition is not satisfied, then else, what about this? If this is satisfied, do this. If this is not satisfied, do this. You can have as many elif as you want. And then if none of them are satisfied, then you come to else, then do this, right? So because I'm going to be asking user to enter something, so let's say import the input. So input will allow a user, right, to enter a specific value. So usually the value that you enter at the int will be treated as a string. So if you want to convert them to number, then you have to specify that, right? So if you want user, a prompt to ask user to enter something, you will use this function called int, right? int. Right, so let me here input. Then, so an example is int what is your name? Right. Then, right, what is your name? Then, what is that? As an input, right? As it's not integers, but input, input. right? So what is your name? Then it will ask user. So if you look at this, it becomes as a string, right? Even if you say input, please enter a number. Please enter a number, right? Then even if the user enter a number, let me leave some space here. So let's say 12, see is a string, right? If you look at, let me assign a variable to it. Let's say num equal this. And then I want to try the type of number. So if it's a type of this number, you will see that it is a string, right? So if you want to have as a number, as an integer, then you can specify here int. Then if I enter 12, then now it's an integer. Okay, let me see if somebody got a chat. Is there a different initialize? Is there a way to initialize? Yeah, right. So you can, yeah, yes, there is, right? You can also, if you want it as a float, right? So what is your salary, right? What is your income? Then you want this to be a float, for example, right? So let's say 20,000. Oh, what did I do? Oh, that. Right. So if I look at that, it is a float. Another questions? Oh, yeah, you can do that.
So I think the user is coming from a programming background where he's saying if I initialize a variable to a type, then when I ask for the input, the variable is going to be of the type. Yeah, which I don't think is true, but
let's see. Yeah, I don't think so. Let's say here num equal integers here 0, and then I will ask user, right, enter a number. So now let's say 4. Okay, let's look at the type. I look like an integer. So. Oh, because of this, let me remove this. Because I'll convert it to a float. So let's say 4. Yeah, it doesn't. It doesn't do that, even if you initialize it. Okay, so let's talk about if else, right? If else. So let's say I want to have a list. Let's say I want to find the maximum of 2 numbers. So I'm going to ask the user to enter 2 numbers, right? Then I will compare the 2 of them, and then I will be printing the maximum, right? So I can do that, or I can also go through a list. Let's say here emp name equal this, for example. Let's say Josh. See. So we got this name, this list of employee name, for example. Right. Then I have a name. Let me so I have this name here. Let's say I have a new name equal this. Let me see, something close to Josh, so John, for example. And I want to check whether or not it is in this list, is in the employee list, for example. So the hard way to do this is to compare this name to each one of them in the list. Not, assume that you have a, you can go through all of them. It's not an infinity of a name. So you can say, this is the hard way. If name equal this, first I'll go Josh, right? Or, right, name equal that. I want to go through all of them. If that is true, then I would say yes, it's an employee. If that's not true, then I would say not an employee. So name equal Alan. So name equal Sarah. Right. So this is now advice. Name equal Sam. name equal Adam. So if that is true, if it is equal to any one of these, then I want to print employee. Yes, it is an employee, or he, or let's just put employee. Right, so else, right, else is not an employee, print not an employee. It's not an employee, right? So this is false, so it will print not an employee, no comma here, right? You can put parentheses, Allen, or that's or this, right? So either this, right? You are comparing to all of them, right? So it's not an employee, but a quick way to do this, because we learned this last time, you can just say if name isn't, so if name is in this employee name, right? If name is in that, if name is here, print employee. Else, right? Notice the if and the else, are aligned. So the indentation is very important with Python. So now here, not an employee, not an employee. So if I change name to Josh, for example, then the both will say it is an employee. Right. So if else, so you check in condition, if that is not satisfied, then else do this. If this is true, do this, else do this. Right. Any question? Questions? Okay, so we can compare numbers, right? So we can compare two numbers to find the maximum. Let's say I want to say n1 equal input. I can say int if I want it to be in integers. So int input. If I want it to be just a real number, I will put float here. So input. Please enter the first number. Please enter the first number. All right, so that, and then n2, I'll say second number, and then I'm going to compare these two. And click on that. So this is what I will do. I will say if n1 is bigger than n2, then I gotta set my max, right? Then let's say m is a maximum here, right? Then if n1 is bigger than n2, right? Then I will say the max m equal n1. So else. So this else is n2 is bigger than n1. So m equal n2. And then you want to print. Now, once you're done with that, you want to print the maximum, right, of the two number is. So if I want, I can use the format method, right? Right. So I'll do this. And then that format. Usually use format when you have more than one parameter to fill in. So I will say here m. So this will return the maximum of the two numbers. Okay, if indentation m equals 0. Oh, that. So let's say 12, and then let's say 13. So the maximum of these two is 13. So let's say we want to find the factorial of a number, right? Remember, a factorial of any number contains itself. Let me see if I can get my pen. Actually, this is an if. So maybe we should go to this is else if. So elif, we can go to elif first before we do that. This is if else. So let's do elif. So elif. So if elif and else. So for example, let's say I'm printing student grades, right? So I can start with if grade is bigger than is greater or equal to 90, return, right, or print A. If grade is less or equal to 90, that would be B, right? Or if grade is greater or equal to 80, that would be a C. I mean, less or equal to 80, that would be a C, and then go on and so on. But I can use the if condition on that. I can also, yeah, let's do that, right, elif. So if or let me get a basic one. Let me if grade. We didn't define function yet. Let me see. Boolean. Yeah, we didn't define function yet. So let me look at the list. We're gonna go to elif. Elif and for loop. Okay. Right here. Okay, elif statement else, and then for loop. Okay, so elif for loop. All right. Okay, so now let's go to for loop. Right. So we got that because of the time elif. Okay, so let's say the list. Let me go to our list of employee. Okay, so I want to go elif going through this list. So I want to check if the first name, if the first character of the name start with A, for example, right? Then I will do something. If it start with J, I will do something else. I will do something else. So and that I have to for loop to it. Okay. Or let me just modify this. So if name equal, if name is in this employee name, then I will do this print yes. So I will say elif. So elif, if the first name, if you start with the first character is equal, let's say you start with J, for example, I will say not quite. Right, not quite. But not sure. And then else. So else, I will say, well, say an example where you can use elif, because I don't want to for loop to it. We didn't talk about for loop yet. So I'll say here, not employed, not unemployed. So we got our name here. Name is Josh. Right, so where am I? Elif? No, not this one. Yeah, right here. Right. So it is yes, because the name was equal to Josh. And then Josh was among the employees. So if I change this to John, right, for example, then if I want this, right, not sure, right? If I change it to this, then it will be not an employee. So that's Elif, an example of Elif. Now, after Elif, for loop, let me look at the chart. Yeah. Short code, yeah. So let's talk about for loop now. For loop. That's the next thing. Yeah, for loop. Okay, I think that's the next thing we need to do. So if you want to look through, let's say, a list of items, and then if some condition is satisfied, then you do this, right? So for example, I have my employee list. I can do this for name. So I would say for name in employee name, EMP name, I believe. Let me have, right? Then for name, I can just say print name. So this will print all the name that is in there. So let's just say print name, right? So you print everybody's, right? Then you can add some condition here. So for, you can say instead of name, you can put X. It doesn't have to be name. Let's say for X in employee name, right? Print name, print X in this case, right? So in fact, you don't even have to have alphabetical. You can have this, except for this in EMP. That print that underscore. Right. Then we'll get it. Right. So you can add some condition, right? Let's say for name, right? In this employee name, right? So if the first character of the name is right, the first character, so that's 0, index 0. If that is equal to, let's say, A, right? Then you want to do something, right? Print name, for example, you print the employee whose name has, start with A, right? So you can do that. Else, then nothing will show. Let me bring this up. So if the first character start with A, you want to print that A. And then what happens sometimes you might have, let me get the employee name. Let me see somebody name here is Abed. That's a lowercase, right? Then you don't want to miss that. If you want to get everybody whose name start with A, then you can make this one lowercase, right? Because if I do like this, I will not get Abel. I won't get Abel, right? Abel is not here. But if I take this to be lower or upper, right? Then it will give me that. So let me put this A. I'll put here first character that lower, right? Yeah, question here. Yeah, you can do that. You can absolutely do that. Yeah, I can do that, right? So now it got Abel, right? It got Abel. So somebody asked in the chat that, can you start with an empty list and then go through everybody's name and then put those names in the list. You can append it, right? So for example, so I would say empty list. So empty list equal this. Then you wanna, for name in employee name, right? So if name sub-0, right, that's lower equal A, right? Then you want to append that. So you will say empty list that append, right? So we talk about append. So you want to add that name there, append name, right? And then after you do that, you want to print your you want to print the empty list, right? So print empty list or employee list. Let's call it that because it's no longer empty. Yes, colon here, and then there should be indent here, right? Then it will come as a list, right? Good point. Yeah. So you can also go through the range of the length of your thing. So you see, we didn't need to specify else here, right? Else it doesn't care, it doesn't just do that. Unless if it does not, then you want to do something else, right? Then you can add it, right? So that's for name in employee list, employee name. So you want to check the length of everybody's name, right? So if that name, the length of that name, let's say you have 4 characters, you know that's divisible by 2. So if the length is divisible by 2, then you will return even, for example. So if len, this is a function, len of name, we will return the length. So len of name, if you divide that by 2, that is equal to 0. Then you can say print even length, for example. So if you want else, you would say add, right? So else print add. Right. So, right. So if you can also print the name along with this length if you want. Right, you can print the name and then say, let's say Allen, right, is even length. No, what is that? Adams will be even length. So you have here Adam, even length. You can do that, right? Okay, so that's for loop. You can now I can use for loop. I can use for loop to find the maximum of the number of factors of the factorials of some numbers, right? So if I pick 12, I know that the number of factors of the factors, let me write it here, the factors of 12, right? For example, you got 1, you got 2, you got 3, you got 4, and you got 6, and you got 12 itself. So regardless which number I pick, I will have the number itself and 1 in there. If I take 15, then I have 1 is there, 3 is there, 5 is there, 15 will be there. Right. So I have to notice that if I'm looking for all the factors of the numbers, so 1 should be one of the factors, and 1 should be one of the factors, and also the number itself should be the factor, right? So let's keep that in mind. I want to make that as a comment so that .z. So I want to comment it out. Okay. So now let me try to find the factors of any numbers, right? So I want to ask the user to enter. So I will say n equal. So let's put integers for simplicity. So integers input, and then we'll say please enter a number. Right. So then here I can print first. Right. I can print first like the numbers, the factors of the numbers are here. I can print before I even I go checking the number, because 1 should be one of the factors, and then n is also another factor. Let me see. Please enter integers. Right. So yeah. So then n, the number itself will be a factors, and then 1 will be also a factors. Right. The number and 1 will be part of its own factor. Now I'm gonna go inside and then check. You see here, I say I equal 2. So I equal 2 means I got 2 factors already, right? And then the number of accounts, this is when I want to count the number of factors. How many are there, right? How many factors are there? So you start at 2 because you know 1 and n already, right? So now you want to see for I less than 1, n over 2. Why I do that, right? Why I do this, because if you look at, let me see, if you look at any number, so if you pick any numbers, right, you take half of it, right, half of that number, let's say 12, right, then if you take half of that number, then half of that number, let's say 6, 12 here, 6, then you don't have any other factor after half of the 6 except the number itself, right? Because 15 is a bad choice, let's say 12 here, and then I come here 4, and I got 2 also, and then 4 here, and then 6 here, and then 12 itself. So behind 6 is a half of 12. Behind 6, there is no other factor except 12 itself. So that's why I want I to be less or equal to n divided by 2, right? Because outside that, the only factor will be n itself, right? So, right, so that's what this means. So I want this I to be less or equal to half of it, because after n over 2, the only factor will be that, right? So let me just copy this here. We want to run. Okay, so let's come here. So I want to print this because n and 1 will be part of the factor already. Now I pick I equal to, right? So that's for now, I'm not going to count the number of factors, right? Let me forget about that. So I will say while I, oh, we didn't talk about while loop. We did, okay, maybe this is an example where we're going to talk about while loop. So while I is less or equal to, so if this condition is true, n over 2. You remember n divided by 2 is an integer division, right? So if the division, the remainder, right, of I, the remainder of your n by I, if that is equal to 0, right, that means I is a factor of n, right? Because, for example, 12 divided by 3 is the remainder is 0. So 3 is a factor of 12. Then I'm going to print that. I'm going to print that factor, right? And then I will increment it because I want to go to the next number and then print I. So let's forget about counting the number of factors for now. So we'll say if n, the remainder of a division of n by I, if that is the equal 0, right? Then I will say print I. Okay, so you see here, I'm saying the n equal here this, n equal this. So I want the factor to be separated by comma, or if I want them to be separated by space only, I will do this, right? Only by space, right? Then I will come here, print I. I need to increment, so I, right, equal I plus. So I mean, if that is true, I'll go to the next value of I. I'm adding 1 to it, right? So you will see this I equal I plus, but some programmer will write, instead of doing that, they will say I plus equal 1. It's the same thing. I equal I plus 1. You are updating, right? So these will be together. I plus equal 1. Now let me put in the usual way since we're learning. So I equal I plus 1. So the new value of I is the current value of I plus 1. Then we're going to print n. Right. So print, and the indentation is very important. Right. So print n. Right. The indentation F is this and this I are indented. And then my print, if I stay inside here, let me come. If I stay in here, oh, how can I move this? Right. If I stay inside here, look what is happening. And it's 12. So let's say 12. You see the difference? So I only want the factors of 12. So that's it. Right. So if you want to count it, then we start with 2 because we know 2 of them already. And then as long as this happens, then we'll increase the count also. Right. I think somebody is not muted. Right. So you start with count equal 2 because we know 2 already. And then we're going to say count plus equal 1. Right. So if you want sum, you do the same thing, and then we can print all of them. right? So you start here, count equal 2. We got 2 of them, right? Then we'll say here, count plus, right? Count plus, or count equal count plus 1, count plus equal 1, right? And then if you want to print, you can say print the number of factor, right? So the number of factor is, right? So count. So if you want, you can do comma, or you can use a string formatted if you want. So here, and then say count. Right. So if this is when you want to count the number of factors, right? So the number of factors, 1, is that right? The number of factors, why we got, oh, okay, 1, 2, 3, 4, 5. So the number of factors of, we start with 2. For each one of them, we are increasing it. Count equal counter plus 1. Let's say 15. Okay. So let me run this and see what's up. Okay, so what am I missing here? Oh, I started 0, sorry. We got 2, we know 2 already, right? Because n and 1, that's the reason. Let me see here. Yeah, now it's working, right? Because we know this and we know this, right? Then that's how you do it. So in addition to for loop, any question about this? Questions? Let me go through the list. What's the next one we need to do? Yeah, for loop. Oh, and list comprehension, and then lambda expression. We need to cover that, right? So list comprehension. So let's say we have this for loop as a let's say here num list. I got a list here for this, and I want to go through it. 1, 2, 3, 4, 5, 6. Then I want to square all of them. So this is what I will do. So for number, or I can say for I in this in num list, then I want to, let's say, new list or square list. Square list equal that. I want to square everybody and then put in the list. Square list equal this, for example, empty. So for num in this list, then I want to append square list. I want to add so square list that append I square. So I square is 2 star, right? Then I want to print a square list, right? Square, oh, I said square. Okay, so square list. I want to print it. So this is the hard way. Square list, one of them are not defined. Square. Name square list is not defined. What's a square list? Oh, this one. That square list. Right. So this will return this. So instead of doing that, you could have used a list comprehension. So I would say list. So you start with let me start with this. In fact, let me copy this. Right. want to copy this and then transform it. Oh, Control Z. So I want to take this. In fact, I don't even need the sequence because we already did it. I'll place it here. So with list comprehension, we start with what you want. So let me delete this. This one, I square will come here. Right. I don't need a kind anymore. So this go away. If I want to make a complete comprehension, so you start with what you want. So take this, put it here. So because we're using list comprehension, so square bracket here, and then at the end you have square bracket also. So I'll say I square for I in num list, and that's it. Right, I square for I in num list. So if I want to see, I will say list, so that I will see it. So let me do that. See, it will give you the same thing. So you don't need append, you don't need to follow through it, right? And the question is, what if you have a F, if else inside your for loop? You can still do it. You can still do that. So let's say, let me copy the same thing. I want to add some more condition, right? So let's say you have this. You got phenomenons there. So I want to, instead of append it, I want to first see if I, right, the division by 2 is not, so I want to see if it is add. So it's not equal to 0. If that is not, if it's not equal to 0, then I want to append it here. Then I will say else, right? So else, then I can just do print out, add. So I print even here. But right, or I will say else, just continue. If it's not, continue mean, okay, maybe we need to talk about continues and then break and so. Okay, fourth line. Are you okay now? Mobolaji? Mobolaji, are you okay? You said fourth line. So I don't know which fourth line oh, never mind. Okay, thank you. All right, so here we have else inside, right? So we still wanna do right. Let's go with if only first. So you got if inside, then we wanna do this, right? So let's do that first, and then we can add else to it, right? So if it is add, we're gonna square it and then add that to our list. So that's what you get here. So 1 square is 1, 3 square is 9, 5 square is 25. So if you want to do a list comprehension, we start with our I square, right? So I square, right? So I want to say I square, right? That's what we want for I in our num list. Right, if I, so I will leave I, the if condition at the end, if the division by I by 2 is not equal to 0, right? And if I want to say, I gotta have a list here, right? List here. So you get the same thing, right? Any question? Okay, so what if you have else and else inside? You can still make you can still write a list comprehension. So list comprehension is easy, it's quick, but it's confusing at the beginning. At the beginning, it's confusing. So if you feel like you make your code complicated, because sometimes you come within your own code, if you're not paying attention, it's very easy to get confused with a list comprehension. But it's very important that you apply list to it, because if I only run this, it doesn't give me, run it here, right? My thing is, usually this doesn't return a thing, but I'm surprised. Okay, maybe Jupyter Notebook has been updated. Right? Usually you have to apply list to it so that you'll be able to see it. I don't know if somebody else is using another editor. Okay, so that's list comprehension. Let me look at the next thing. After list comprehension, I want to follow these. Okay, lambda expression. So if you don't want to use, you don't want to use a space for a function because that you want to use it over and over. You just use lambda one time inside your code, right? And then you use it, and then that's it. You don't have to worry about it or any extra space or memory, right? So people use lambda for those kind of things. So for example, I have this for loop. I can write a lambda expression. I can say lambda. I will take number, so space, your variable, and then you define the operation that you're doing on the variable. So let's say I want the variable cube, for example, right? And then here I have to specify where this number is coming from, right? So it's coming from, let's say my what is it, num list. So from num list, right? Num list. So lambda can do this for you easily, right? It will cube everybody from that, right? Yeah. Would you be great if you record and they're available? I think they're recording it, right? They're recording it. Right, Stacy? I think they are recording it. Somebody asked that.
Yes, yeah, it's
Okay.
being recorded. Yeah.
Okay, so all right, give me 1 second. Filter. I guess that's the next one. Yeah, map and filter. Okay, so at this point, to some sets. So we got to define function first. To some sets. So what do we do? Oh, map and filter. Right. Lambda is very useful. You'll be using this a lot, especially inside your data frame, right? So lambda expression, after lambda expression, what do we do? Oh, map and filter. Right. Map and filter. I guess that's the next one. Yeah, map and filter. Okay, so at this point, yeah, we should have defined function because map usually map a function to some set. So we got to define function first before we come to map and filter. Let me go to functions. So in Python, functions start with def. Right, you wanna always start with a def. So def, the name of your function usually lowercase. So name of your function here, and then this open and close bracket. Some function take parameters, some function don't, and then you should always have this here. If it does take the parameter, then yeah, let me see somebody got questions. The best way I heard being explained. What is the benefit of this? Yeah, the benefit of this, you don't have to is space memory. You use lambda one time, that's it. But if you write a function and then you call a function, you are using space, you are using memory, right? Lambda just spaceless. You call it one time and that's it. You're gone. Yeah. All right. So you start with a def, the name of your function. If it does take parameter, then you put right here params, right? Parameter here, and then you will have some stuff here, right? What you want the function to do, right? Some operation here, right? You have some operation here, or some just sometimes you might be just printing, or sometimes it might just be saying hello, and then some function return, right? Some function just print stuff, right? So this, you got these two options to return
right? Or you can just have a function that just print, right? So it will do, the function will do whatever you condition you impose here. So you define your function, you want some operation that take place, and then you want to return the results after the function is done doing that, right? So let me comment these. Right, so basically that's how function works, right? So for example, let's say we want to write a function that will just take the square of every number, square root, right, from our num list. So you will say def, right? Usually the name of your function should be similar to the job of the function, what the function is doing, right? So if I'm taking square, I will use somewhere close to that. If I'm taking root of numbers, so it's a root num, for example. So it becomes easy to remember. So I would say here, it will take num, it will take this parameter num, and then here, what I'm going to do, I will say this function, I want this function to return, for example, return num. Why my return is return num to the power 1/2, right? So power 0.5, right? Right. So, and then I don't have to specify the num list. All I need to do, I need to feed in any number in there, right? So if I say root of for 4, for example, that should give me 2, right? If I say root of 3 with 3, right? Root of 1 is 1. So it does that, right? So usually people write function, right? And then save it somewhere, and then every time they need it, they call it, right? Remember, it's easy to remember the function that you built to call it, and a Python built-in function. Most of the functions that are building here, they are built in Python already. Python has a version, right? But if you can build your own, that's a good way to learn Python also, right? So that's how function works, right? And then this indentation is very important. If you come here, you will say indentation error, right? So the return and the def should not be in the same line, right? So you gotta have this. Yeah. So let's go to other functions. So df. So I will say add. This add function. So you would take parameters. So let's say first val. So val 1, val 2. Right. So what it does, it will take this. It will just add. So return val 1 plus val 2, right? Or you can say here sum, define this variable sum equal val 1 plus val 2, val 1 plus val 2, and you want to return sum here. Right, so let's see, sum is a keyword, but let me see a sum. Right, so that's fine. Then that says our sum equal this. So if I call add function of 1 and 2, it should return 3. Right. So inside a function, you can have conditions. You can have conditions inside the function as well, right? So let me see some of the example. Let's say we want to reverse a string. We want to write a function that reverses a string. So let me show you what Python built-in reverse is. So let's say you got A, B, C, D, that's your strings. If you want to reverse this, right? So it's S, you do this, double colon, and then you do -1. So that will reverse it. You see D, C, D, A, right? So let's say I want to build my own function that will do this. Right? So I can say df, I can call it reverse func. Right, so you take a string here. I'll just take val. Right, so, and I would say for character in this val, right? And I want to start with some empty. I want to start with some empty characters. So I would say new string equal this. So I'm going to append, you see what will happen. So for character in this val, right, I'm going to them, and then I want to say new string. This new string right here, I want to, new string is equal this val plus new string. So the position is very important. If I change the position, it will not reverse it. And then let me do this. And then I want to return it, right? Return new string. Return new string, for example. All right, so let's say I want reverse of yup. Oh, what happened? Let me run this. I got it twice. So for char, oh, it's taking the, yeah, I need to split it, right? So I need to split these, right? Because it's taking the whole thing at the same time.
Yeah.
So
I think if you replace var on line 1, 2, 3, 4, just below your cursor with char, because the four will split it, right? The for splits your var and puts it into char. And so when you, so on the next line, instead of var, if you make a char.
Yeah. Oh yeah, yes. I'm taking char in there.
Yeah.
So is it called char plus new string? Yeah. I think, let me see, your boy, okay, very good. So now let's say instead of doing it, this is very important. If you change the position now, put it here. Yeah, it's a char that I'm taking from D. So see, it doesn't do it, right? I have some special word where the reverse give me, let me see, the reverse.
Actually, if you have character plus new string, then it works and it becomes boy.
Yeah, I need to replace it. So new char.
Just switch it.
Yeah, if I do this, but I have to new char on the right side. This is the case. You gotta have it to the right side here, right? So what was happening here? So it will go through my val. The first letter is, the first character is Y. So it will add empty string to Y. So you will have Y only. And then the next one will go to O. Then now it will add a O to Y. So it will be OY. Then the next one is B, then as a YO, right? Then the next one will be B. Then B will be on the right. So Y is there. Y is a chart. The chart is always on the left. And then the new one will be on the right side always, right? So Y first. When you come to O, then it will be Y plus O. When you go to Yob, so Y first. The next one you go to O, then it will become Y O. Then the last one is D, then it will be Y O B. Right? Become boy. I have a lot of words whose reverse give you some sense. I have them here because when I was yeah, if you reverse them, you get yeah, this, like all of these words make they have meaning, right? This, so a Google word whose reverse give me another words. I think they have a special name for them in English. So this is a company that Oprah created. So when I reverse it, it gives her name, right? And then this one in reverse give you, so Yense give you is a music band. So when you reverse it, it give you Disney, right? This company belonged to Oprah, which was interesting. Right? Maybe they look at her name and then reverse her name to give that name to the company that she owned. Right? So we can do a lot of stuff with functions, right? So now, because yes, so kind of like yeah, kind of palindromic. You know, they have to satisfy some conditions. They have to be prime and then so on like that. So palindromic is more than this, I guess. Right? If you reverse them, the reverse is equal to themselves, right? So if I want, that's interesting. So if let's say I want this to be a val instead of let's say a string here, because if I don't use this, if let's say I'm converting to a string, for example. Now, instead of this, let's say this is a palindromic number or somebody's, right? If I do this, it will give me exactly the same. So number who reverse equal themselves, and then they are also prime. Forgot about this, right? This is palindromic number also. Good point though. It's been a while since I talked about palindromic numbers, right? Okay, so right, so this function that right here does exactly the same thing here. The question is why you should do this. Sometimes you will have more flexibility with your own function. You can add some restriction to it, some condition than the built-in function itself. Okay. So we define functions. That's not it. So after that, the function lambda. Okay, map and zip. Okay, map and filter. So now we can map our square function. Did we define square or root function, right? And let me make sure our num list is in this. Yeah, it's in here. So we can map this. We can map this square function or root function to this root function here. So what map will do for each member in the list in this list here, it will take the square root of them, right? It will take the square root of all of them one by one and then return that result, right? I think I have some good example here. Let me see. Map. Okay. Okay, so yeah, so we have our numbers and then we got this is 3 times, so this could be our root. And then if you want to say an output, you need to apply our list to it, right? So we have the root function, so we can say map. So our root, right? Root function now is root num, okay? And then we're going to apply that to our num list. So it will take the square root on all of them. Right? So if I run it like this, then I will only get this object. But if I want to see some output, then I would say list here. And then this will give me the square root of every number that is in this list. So you can also use lambda inside this thing. Now I can use a map. So we have our root. Let's see, lambda. So now I would say, and then I would say num square. Right, and then here our num list. Right, again, you don't see anything. If you want to see, I think, right, you need to do this. It will give you the square of all the number that is in this thing. Right. So you can use lambda or you can call your function inside, right? This is the function that we build. This is the lambda that we just did here. See, the beauty of lambda, you don't have to create an extra space for your thing. You just, call it inside of your, right? You will do this especially inside your data frame. You want to do something, you want to convert the date column to some specific format. You can just apply lambda inside of, right? Okay, so filter, right? So we want to filter, right? So filter, right? So you will be checking some condition and then you will filter those out. So you will go through a list, for example, our sequence from 1 to 5. So what this filter will do, we'll go through each one of them and then return the one that are square, right? So I would say filter, for example, so we want to check lambda. So say I have name, right? So name first character equal a, for example. Now I need to use our emp list here because I'm going through the list. So employee name, I think that's what we, right? So we will go through each one of them and then compare the first character in the name and then return that. Right. So if I want to see it, I'm gonna write the list this here. Right, so that. And then again, if I want to get Abel, then I need to see here that lower, right, lower. And then if the lower case is for this, then I want to have Abel inside it. So filter, it will filter out some condition, right? It will give you the one that satisfies the conditions, right? However, map, can you have all condition in your filter? Also consider low picture. Yeah, you can do that. Yes, so you can say equal this, or right, you can have this condition. I don't think I did this before. That would be or if it is the upper equal this. I never done this inside Lambda, but I think it's possible. So if employee first name in lowercase equal that, or in uppercase equal this, then we want to return that, right? So or we got two conditions here. Right. So let's see. Yeah, it does. Right. Is that what you mean? Okay, yeah. So yeah, you can do that. All right. So filters. No problem. So let's say we want to, let's say temperature equal this, and we will have 0 degrees, 0, 10, 20, 30, 31.5, for example. And then we want to convert these. These are Celsius, right? Celsius, that's a Celsius 10 for this. And then we want to convert it to, Fahrenheit. So Fahrenheit 10. So we can use list comprehension here, right? So what do we do? I think the conversion is what? 9/5. Is that it? So 9/5 times, let's say T plus 32 for T in Celsius. So I'm hoping that this formula is right. I think 9 over something, right? So you can use list comprehension to do that, right? For T in Celsius. So it will go through this and then just do it, right? Question, message, no message, okay. All right, so, right. Let me see what is complaining about. Oh, comma. Right. So if I look at temperature in Fahrenheit here, all of them has been 0 degree equal 32 degree Fahrenheit. Right. So think about it. You can use lambda also to do this. Right. Questions. Oh, 5/9. Oh, this is when you want to go to from Fahrenheit to degrees, or from Celsius to Fahrenheit. Oh, from Celsius to Fahrenheit. But Fahrenheit is the biggest one, right? Yeah, Fahrenheit is bigger. So I believe this is Fahrenheit. Celsius is the reverse.
Yes, you're right.
Oh, okay. Okay, so that's that. I got a lot of examples of functions. Okay, so now let's we got up to filter. Okay, we'll cover all of these: if comprehension, lambda, expression. Okay, there are 2 questions here. How to limit digits to accuracy? I think there is a way to format it, right? I think there is a way to format it. Let me look at the second list. Oh, we didn't talk about range and length, right? We talked about length, but I don't think we talked about range also, right? I think that that's something that we need to mention. Okay, so Celsius is 5/9 times Fahrenheit minus 32. Yeah, that makes sense. We can even do that, right? Okay, so let's look at this example. Maybe I should let you think about it for a few seconds. So we want to write, I have an exercise here, find the numbers or count, let's see, count primes numbers. Primes, okay. I would say write a function that returns the number of a prime number between the axes that return the numbers of primes numbers, right, that exist, right, the number of prime number that exists between, so I would say between that exists up to including a given value, right, that exists up to including a given value. So here we need to discuss range first, right? Because if you want to include the given value, let's say for example, we want to include find the number of prime number between up to 100. So from 2 to 100, right? So let me put this as a markdown cell so that it becomes nicer, right? So we need to discuss range. If you see range, right, let's say for I in range of 10, for example, print I. So this will print from 0 to 9 because range does not include the endpoint. So I would say print I here. So you see 10 will never show up. So if you want to print number from 0 to 10 included, then you need to have this, right? So from 0 up to 10, the last point is not included. So you can also indicate the starting point, right, the end point, and the step point, the step size, so 1. So from 0, you come to 1, 1 to 2, 2 to 3, up to that, right? So in this case, you get the same thing, right? If you want only even numbers in there, you can do that, right? If you want only odd numbers there, so from 0, you do that, right? So range does not contain the start point, the last thing, it does not contain that, right? So that's something that we need to keep in mind. So if we want to get prime numbers that are between, let's assume that 1 is not part of it, so 0 is not a prime number. So we're gonna start from 2, right? 2 as the first prime number. So from 2 up to 100, so including 100, right? Then we can use range here, right? In fact, you can use range from, you can use the beginning to be 2, and then the endpoint to be 100 and what? If I want to include 100, what should be the start point? Anybody? So let's say def, we're gonna call it count prime. It will count prime numbers, right? So those prime numbers. Now we know that 2 is the first prime number. So let me start by initializing this prime is a list that contains 2, right? But I'm going to find others, right? I'm going to find others. And if I find all of them at the end, I'm going to measure the length of these primes, right? If we have 2 elements, then right now, if I take the length of this prime, let me do it here, it will just be 1. It is a list that only contains 1, right? But I will be checking for others. Now, if you do length of primes is only 1. Right? So that means it's only got 1 prime number is in there, right? So let me delete this. So the objective is we're gonna look for others prime number that will be going to these prime numbers. And then once we exit the list, then we're gonna measure the length of these prime numbers, right? So I will say x equals 3, for example, right? Why I'm doing this, I'm gonna be checking numbers that are between 3 up to our numbers, the number that is given, right? because 2 is the first prime number, and I will keep on adding. From 3, I will keep on adding 2 to it. So from 3, the first, if I add 2 to it, that becomes 5. So 5 is a prime number. If I add another 5, 7 is a prime number. If I add another number, it becomes 9. I have to check every time I add 3. I will check if it is a prime number. Then I will append that. I will append that number to our primes. For example, if I add 3 to 2 becomes 5. 5 is a prime. It will be appended to our prime. Right. So to do that, we're gonna roll out the case for 1 and 0. Right. So we'll say if we pick a number that is we want to find, if a number is less than 2, right? If that number is less than 2, then we're gonna return 0. There is no prime number between that. So return 0. Oh, not 0, right? So now, if else, now we want to check while the number is our x that we hear is less or equal to our numbers, and then we're going to increment it. So we rule out 0 and 1. Now we want to see while x, right, is less. We want to put equal because up to including the number that is given, right? Less or equal to numbers, right? Then we want to say if, right, y, so for y in the range, this is why it is interesting to get x equal to 3. So for y in the range of x up to number, up to num, right? So we want to see for y in the range of x is increasing, we're increasing x will go up to n. So I want to say for that, and I will increase the step size 2. That's what I'm doing. So the first number is 3 at that. The second number will be 5. If it is a prime, I will check that later on. So now this is what y will go through, right? Why we're going through this range, the step size is 2, right? Remember here, if you change the step size to 2, it will keep on adding 2 to 0. So 0, 2, 4, 6, and so on. So now we want to check if, right, the remainder of x and y, right? So we want to say if you divide x by y, if that remainder equal 0, right? If that is equal to 0, then what we're gonna do? What does that mean? You remember x can go up to n, so and then y is in this range. So let's say x equal 5 or x equal 15. Let's say y equals 3, right? If it is divisible by that, then we're gonna increase x. We are going to add 2 to x, right? So if it is divisible by that, then it is not a prime. If it is not a prime, we're gonna break it. Break, right? So if that doesn't happen, right, that means it's a prime, right? If it doesn't divide, then this thing is a prime. Then I want to say else, right? You notice my else statement is aligned with the for loop, right? Because I have a break inside my for loop here, right? So if this doesn't happen, then I'm out of it, right? Then I want to see, that means I have some prime numbers here, and then those prime numbers will be appended to my prime. So then I will say our primes, I would say that append, right? Let me put it up a little bit. So that append x. Now we're gonna increase still, right? The step size is 2 always. So x, the new x is equal x plus 2, right? And then at the end, we're gonna say, yeah, range, you're right. I forgot the range, thank you. In the range here, thank you. Right, so then now I'm ready to print. I can print the primes, I can also print the length of that, right, or return. So let's print first, print primes, and then return the length. Print primes, and then the function will return, right, returns length of our primes. Right. I have a feeling that this is more mathematics than programming, right? So let's see. I want to print this here. So let's say primes of 100, for example. Right. So that's that. It print all of them, and we have a number. So there are 25 prime numbers between, I would say between 1 and 100, right? But I think this is the tricky part, right? You keep adding 2 to 3. Why I do that? 2 to 3, you keep adding the steps like 2, 2. Those numbers are more likely to be or even. But if you take a 2 here, any multiple of 2 will not be prime numbers. Any multiple of 2, 2, 4, 6, those will not be prime numbers, right? Okay, so questions? Okay, so we can take a break and then come back. It's 12:52. We can come back at 1, so 15 minutes, 1:07. Is that okay?
Yeah, yes,
John,
let's
I
take
think
10
John is
minutes break and then come back 12:40 to continue.
Thank you.
And those of you, if you are staying and you didn't have the chance to introduce yourself yesterday, now is the time for you to do so.
I'll take the opportunity. Hello, everybody.
Sure, go ahead. If you don't mind, would you put your camera on?
Yes. Can you see me?
Yes, I can see you. Is it Alu Kamara? Sure, go ahead, Kamara.
Good afternoon, everybody. My name is Aliyu Kamara, and I am a junior marketing major. I attend Howard University. Was there a prompt that we had to do yesterday? I came
No, it was just an informal introduction. I mean, a chat, so that if you are waiting, if you need to take 5 minutes break, that is fine. But
Oh, okay. No
that is what we do during the break for those just introduction. So who is next? And then also you want to tell us why this training is important to you.
Oh, this training is important because I think it's interesting to learn about computer science principles and kind of approach Howard through an interdisciplinary lens. So just because I'm an SOB doesn't mean I shouldn't learn. But
all right, thank you, Aliyu. Anybody else?
Sure, I can go. Good afternoon. My name is Lamarcus Wingate.
Sure, Lamarcus, go ahead.
Sure, I am an associate professor in both the College of Pharmacy and then the College of Graduate Health Sciences in the Pharmaceutical Sciences program. So I actually do data analysis in my work. I also serve as Director of Assessment for the College of Pharmacy. So I just want to be able to learn how to use another type of programming language and also learn more about machine learning because I am going to be teaching a class with regards to machine learning as a part of a mini grant, which I received here last semester. So glad to be a part of the class and learn more about it.
All right, thanks, Lamarcus.
You're welcome.
Anybody else? So if you didn't have a chance to introduce yourself yesterday or last week, now is the time for you to do so. Or if you don't have mic, camera, you can type it in the chat area. We'll read it for you. So Emmanuel Owusu-Mensah, if you are here, you haven't introduced yourself, you want to do so. If you've done it already to yesterday or last week, I mean, then no need to repeat it. But if you haven't, feel free to introduce yourself.
Okay, thank you, sir. Hello, everybody. I'm Emmanuel Owusu-Mensah. I'm speaking from Ghana, Kwame Nkrumah University. And I had the opportunity through Professor to join, and I'm happy to be here and to learn about Python. I've been a little introduced to R, and I'm happy to also add Python to my my packages, tools I use. Thank you.
All right, thank you, Emmanuel, for coming. Anybody else?
Thank you, sir.
Introduction time. Is it Anahita? If you are here, have you had a chance to introduce yourself? If not, now is the time for you to do so.
Yes, hello. My name is Anahita, and I'm on second semester of pharmaceutical sciences. My research will be focused on pharmacokinetic, but it's not clear for me now. And I'm joined to this class since my professor recommended it to me, and I should learn Python for my research project in future.
All right, Anahita, thank you for joining.
You're welcome.
Anyone else? Is it Roland Langren? Roland, if you are here and you want to introduce yourself, unless you did it yesterday, then that is fine. So we have about 1 minute left for the introduction. So if you haven't had the opportunity to do so, you want to do so now before Dr. Dumbia takes over. Okay, so I see someone posted in the chat area. I will read the introduction to you all. It says, good afternoon, everyone. Sorry, I don't have access to mic or camera right now. My name is Adimola Abdul Kadir. I hope I'm pronouncing it right. I recently graduated from University of Maryland, Baltimore County with a BA in philosophy. I'm pursuing a master's in data science. And this workshop is a great opportunity for me to freshen up on my knowledge of Python and statistical analysis. Thank you, Adimola, for coming. Nice to meet you from Temi. Anyone else? Okay, so Dr. Dumbia, so it's all yours now. Take over whenever you are ready.
All right. So
NP and import by convention NumPy and NumPy. So NumPy is just like a linear algebra library for Python, right? So SymPy is like the MATLAB version of Python, right? So to use this library, I'm gonna import them first. I would say import NumPy as NP, and import. By convention, people use as NP, so you can use any name that you want, and SymPy as SY, right? So I want to import these two. In fact, yeah, let me limit myself to those. So I can create an array for array of NumPy arrays. So I can define the following. Some people still have problem to sign in with that Slack. Okay, so my first array I would say is equal to NumPy. I already called it, so I would say that array, and then I can fit in here a list. So let's say list 1, 2, 3, 4, 5, right? Then, right. So let me define a second one. So the second one is this. So I can put this 5. Let's say -11, 0, and 2, right? Randomly. So we have these two. If I check the type, if I say array 1, right? Array 1 underscore 1, right? Is an array, right? So the difference between these, it looks like a list between that and our conventional list. Let me see if I can create a list here. Let's say L equal this 1, 2, 3, 4, 5, right? So let's say I do L times 2, and look at the result. So it just multiply that list. You produce it again. Are you saying to make it easy? Okay, right. So if I mean to multiply every member in that list by 2, but this is what I get, right? However, if I take array 1, right, array 1 times 2, that's exactly what it will do, right? So it will go inside and then multiply, element wise, multiply everybody by 2, right? So this is the same thing as L plus L. So if I do L plus L, right, it's the same thing, right? However, if I do R1 plus R1, it will be different from this, right? So we can add this array 1 plus array 2, 1, right? So plus array 2, array, right? You can add it to become a new array like this. We can also multiply them, right? So there is a lot of way to multiply an array. You can also check the length, right? You can do array 1, right? So let's say that. So this is that product between the two. So that's array 2. Array 1 that array 2. Right. So this should return a number, finite scalar, right? So instead of that, you could use also, let me copy this, array 1, right? You can do array 1 at. So at symbol will also do this. The at symbol will do it. What happened to my at symbol? Shift at. Yeah, so that should also give me the same thing, right? But the hardest way is to look through it, right? So you can say, you can go through it. So that's, you start with that equals 0, and then you look through it. So you pick element wise. So for I, J in, right? So you go to, let me zip it. So zip in zip, array 1, array 2. So array 1, array 2. For ij in that, then we are going to multiply component wise. So I will say my dot, right, is equal, my dot plus is equal to I times j. And then I want to return look what did that look like, right? So this should give me 2 also, right? Right, so you can do that. You can also do square root. You can take the square root of an array. You can broadcast array, right? So you can add numbers, or you can access elements. So for example, array 1, if I want to get the first 3 numbers, I will say from the first up to 3, right? You see index 0, that's the first one. Index 1, that's the second one. Index 2, that's the third one. And then you remember this does not include 3. 3 is excluded. So this should return the first 3 members of our array 1. So 1, 2, 3, right? So if I only want the last number, then it's -1. If I want only the one in the index 2, like this, right? So like this, you can do those the same slicing that we did in the list. So now you can replace, let's say I will say I'm replacing in array 2, I am replacing, let me see, array 2, for example, I'm replacing the second number by 100 because it's negative. So you can say array 2 at 1, that's the second member, equal to, let's say 100, right? And then if you look at, 100. And if you look at array 2, right? So that -9 has been replaced by that. Right? It has been replaced by that. So you can also create, so let's say array 3. You can use this array 3, I will say up square. So from the beginning to the end, that's what this means, right? I want to say I want all of them to be some numbers. So let's say 0. Then if I print this array 3, I will get 0 zeros. What did I do? Array 3 at I need to define array 3 first, and then I'm going to replace all of them by this 0. So array 3. I will say array 3 equals something here. Array 3 equal 2, 3, 11, 5, 75, 22, something like that, and then 8, 9. So this is my array 3, and I want to say replace all of them with this 0. Array 3 equal that. Cannot iterate. Let me look at my array 3. Okay, let me see from 0 to 3, for example. I wanted that to be equal to 0. Okay, only iterate for sign there. Let me take this out. Only one can only assign iterable. Let me look at my array 3 again. Yeah. Okay. See, that's 0, and then look at array 3. So look at it now. That has been replaced by 0. So I was trying to slice it.
Now, do you need for multiple indexes? Do you need multiple assignment? So it's saying
yeah. I wanted to assign from 0 up to 3, for example.
0,
all
1,
of them.
2, 3.
Yeah, I wanted to replace them by 0. I don't know why it didn't work.
Can we try the 0? Let's repeat. Let's make it like a set 4 zeros and see.
Like
it should have worked. Yeah, it should have worked.
Like this?
Yes. Oh no. Square bracket, which is a
list.
The list, yeah, and then 0, 0, 0. Oh. 0. Let's see if it's positional. It shouldn't have been, but
yeah, it should have worked. Oh no, this one worked.
Yeah.
Wow.
Yeah, this is saying because your number is 0, 1, 2.
Yeah, yes. But I used to.
Yeah,
I think
I should have worked.
I used to say just equal to 0.
Yeah, I should have worked.
Yeah, but something is going on, right? So you can like hey, hold on 1 second. My Wi-Fi on campus is not stable, so I'm teaching from home. Sorry about that. Yeah, so we have the option. To replace the members, right? All of these are important. Now we can build. The most important thing about this thing is matrices. So we can build matrices of these. So let's see, my map matrix equals. So first, I want to build it of array. So NumPy that array. Let's say I want to build a 3 by 3. So they have to be inside a list. Your rows has to be inside a list. So you have a list of rows. So row 1, comma, row 2, comma, row 3. If you want a 3 by 3, it has to be, they have to be inside a list. Now, and then each row also has to be inside a square bracket. So unless I want a 3 by 3 matrix, for example, then I'll do this 1, 2, 3, right? And then here 4, 5, 6, and then here 7, 8, 9, right? Then if I print my matrix, it should give me that 3 by 3, my math. Right. So is that so? The difference between matrix in SymPy and NumPy, this is not the usual way that we used to see matrices. SymPy will print it the way we used to see. So let's say I would say SymPy math. So here you will say SY, right? So you want to apply that to a matrix, right? So you gotta have an object M. If you use lowercase m, it will not work. So now you can specify. Let me copy this, and paste it here, right here, right? So I have my list of rows in there. Then if I print SymPy matrix, SymPy math. This is what we are used to see matrix, right? But they're all matrices, right? So we have a lot of type of matrices, like 0 matrices, 1 matrices. So if you want, for example, if you want to build a 0 matrices using NumPy, so I would say Z equal to, for example, np.zeros, and then if I want a 2 by 2, I will mention that here. Right? If I want a 3 by 3, I will mention that here, the dimension here. But you have to mention the dimension. So if I look at Z, right? Let me see. Z is a zeros matrix, right? And with NumPy, you should take a tuple. Let's say 2 by 2, right? With NumPy, you gotta enter as a tuple here, right? So it's a matrix with all entries zeros. Well, you can do the same thing with NumPy, with SymPy, right? So SY, so is equal SY dot zeros, and then here, I think it doesn't take a tuples. Let me see. Yeah, you don't need tuple for that. You just enter them one by one. But with a NumPy, you gotta enter as a tuple. So that's the difference. You're using NumPy, you gotta enter the dimension of the matrix as a tuple. But with SymPy, you don't. You just enter your stuff there. Right. So we have things called ones. Right. So let's say O or ones is equal in NumPy is NumPy that once. Right. Then you specify the dimensions. Right. So if you look at the ones, right now, if you want it to be 3 by 3, then right, that have to be a tuple also. So it's a 3 by 3 matrix, right? So if you want to do the same thing with SymPy, so let's say ones. So that one's equal SY dot ones. And then we're gonna specify the dimension here, right? Let's say 3 by 3, right? And then if I look at ones, right, is that. So the identity is eyes. Maybe we should write here matrix. with all entries once. Right, so using SymPy. Right, I really want you guys, when you're doing this, have some notes, matrix with entries using NumPy. Right, you do the same thing for these. So identity, you just let's say I equal and NumPy dot EYE, right? And let's say we want a 4x4. So let's look at I. Right. So for this identity, even if you are using NumPy, you don't need a tuple. You just enter the thing. This is import NumPy 3x3 equal the.
Primarily, what I'm saying is for visual, SymPy seems to do a better job than NumPy because it gives you, like you said, so it gives you that visual.
SymPy, you do everything you do in NumPy, you can do in SymPy. This, but SymPy is but in data science where people use NumPy a lot. Right. Few people use SymPy. I use it for when I teach data science. I use SymPy, but okay. So if you want to use identity using SymPy, so let's I4 or I5. I want to use a 5x5 is sy dot EYE also, and I want a 5x5 matrix. Then let me print it out I5. Right, so it's a 5x5 matrix, identity matrix. Right. So let me create a matrix, and then using that matrix, we're gonna get the diag, or maybe my maths. Right. So there is a method called diag. It will return the diagonal entry of your matrix. Right. So you have the so let's say D equal sy diag my math. So let's look at D. Let me, instead of math, let me use NumPy here instead of sy. I think they have different meaning. So it means 1, 5, 9 are in the diagonal. So let me print my math here. My math, 1, 5, 9. So that's what is in there, right? So let's say D1 equal NumPy that diag. So instead of assigning matrix in here, let me assign tuple. So let's say 1, 2, 3. 3 here, and then I want to look at D1 here. So it will return. So this is like an overpopulated function. So it will return a matrix with diagonal 1, 2, 3, 1, 2, 3, 4, right? So D2, let me see if I SymPy the diag. Then I want to do this. That's give me 1, 2, 3 equal D2. I think there is an error here. Let's see, it just return that. And then if you put it as a list, then it will just return you that column matrix. Right. Okay, so diagonal, what else we can do? Inverse. Yeah, we can do inverse of a matrix also, but you gotta make sure that the determinant of the matrix is not equal to 0. Right, so let me check np.det of my maths. My maths, is it copy still? np.det. Let me see if I do my math. So I say imv is equal to my maths.imv, for example. So I need to call linalg on this one, right? So I need to call linalg numpy.linalg.imv, then it will work. Right, but with SymPy, I can easily do this. Right, let's say, did I build any matrix with SymPy? What that is invertible? Let me see. Okay, SymPy math. Right, with SymPy math, I can do this. I can say So that INV, right? Simple math that INV. So this should return the inverse of this simple math. So let me look at this INV here. What? It's not invertible. The determinant equals 0. So that's very important. So let me just change it. My simple math, I'll just change something in there, right? So this is 0. Let's say this is 11. I think it should work now. Yeah. So if you look at it, so this is the inverse of our simple math, right? So we can do the we can multiply matrices together too, right? We can use an @ symbol. We can also use a mat-mult method, right? So if I want to make sure that simple math and an INV are inverse of each other from algebra, linear algebra, we'll do the multiplication. So that simple math, if I do that, it should return identity matrix because they are inverse of each other. Right? If this doesn't, order shouldn't matter. If it's a simple math, that mat-mult and INV here, right? This also should return. Actually, I should do this mat-mult. Let me simple math. I'm doing mat-mult between these two, so I call them. Order doesn't matter. So let's do this. That. Right. So they should return identity matrix also. Right. So you do. Actually, let me reverse the order here. Put start. So I want to use INV here. So I'm multiplying simple by INV. In that case, you should get a 1, right? But you can also populate your matrix using random numbers, right? So you just need to specify what type of random number you want. You want random integers. You want numbers that are uniformly distributed between 0 and 1, or do you want, right? So let's say, for example, R for random number is equal. I would say, let me use a simple matrix so that matrix. So inside here, I'm going to call random number. Oh, I didn't call random, did I? I don't think I called random. So I'll just say import random here because I'm going to use it. So I need to call it before I use it. So import random. Right. So now I can call the random thing here. I would say numpy that random that one integers. So run int for integers, and I want, let's say for example, I want integers from -7 to +3, right? And I want it to be like a size to be equal a 2x2 matrix, for example. I'll have to specify size equal a 2x2 or 3x3, so 2x2 matrix, and I want to print that matrix R, right? It is a random matrix because if I run it again, look at this. This is -2, -4, -7, 6. Let me run it again. You see, I get another matrix, right? If I run it again, every time I run, I get different matrix, right? So SY. So if you want to get a diagonal.
John, do you want me to move on to data frame? John here.
Yes, I'm here.
Yeah. We almost got 1 hour left. Do you want me to go to the data frame video or just keep this on?
So we have 1 hour, right? So yeah, let's do the data frame. If this is more kind of algebra things, yeah, let's do the data frame rather. Then again, participant, thank you for coming there. Recordings are there, so you can take your time and then review them if you find this aspect of it interesting.
Okay. Let me share again. I don't hear anything. Let me share the note. The sound. Can you hear? Let me stop everything and share again. What's going on here? Okay, maybe I should start this first. Yeah, this one starts. Okay. Let me share it again. I share the sounds. Okay, so let me. You cannot hear, right? Because I cannot hear either. Let me open the video again. Okay. So what we did here, we create data frame based of these lists and dictionary. You have 1, 2, 3 lists and then 1 dictionary. I hope everybody see that. So build data frame of those.
So, Musa, if you started with the recordings, I don't think we can hear you at least. I can hear, so you want to check on that.
John, you say you cannot hear?
No, I cannot hear. I can hear you speak, but I cannot hear from the recordings.
Oh, okay. So did I equal my list? That's the same thing. And then I can build it off an array. Can you hear now? So PD.
Yes, I can hear now.
And then data equal array. So again, I didn't specify the index here. So if I want the index to be equal to the label, then I will just mention here. Let's say, for example, let me just type, so PD dot series
So the data is a array index equal labels. So it's the index instead of 0, 1, 2, 3, 0, 1, 2, it become ABCD. Right. So the dictionary is interesting. You don't need to specify the index because it's that, you know, it already have it. That you just type PD.series, PD.series, and then it will take your dictionary. What name did I give it to? My dictionary. Okay, dict. Hope it's not a keyword. Let me. Okay, it look like a keyword. So let me do that to avoid any conflict. Right, then directly you will take your key as the index, right? And then your value will be the column value, right? So let's look at another example. So let's say I have the following series, right? So I have the index is equal to this, right? Well, you can reset the index to whatever you want, right? Index equal true, you can reset the index, but series alone is not that interesting. It becomes more interesting, especially when you have a collection of series. A collection of series is nothing but a data frame, right? So collection of series. So let's learn how to make this data frame from scratch instead of series. So we're gonna have a collection of them. So I will need a random. I want to build my random data frame. So I will say df is equal to pd that data frame, right? And then here I will call my run n, right? So npd. So run n. So this will return a sample of a sample that is normally distributed. I think I have a lot of messages here. GitHub update. Okay.
I think most of it have been answered.
Huh?
Most of the questions have been answered. So
okay, I wasn't paying attention. So I want to have 5 rows, for example, and then 4 columns. So I need to, the index should be 5 also. So I will say index, right? So you have many ways to construct it. You can say index is equal, you can have a list, but here I want to get my ABCD also. So A, B, C, D, 5, so E. So I want to split this, that split. When I split them, I want to split them on empty string. I'll write this empty string here. I want to split them on that, right? So that would be, so the first value will be A, second, right? First row will be A, second B, third C, and so on. Now I want the columns. I can build the same thing. I would say columns, columns equal, I can take X, Y, Z, W, I need 4 of them, right? X, Y, Z. So W, X, Y, Z, that's 4. And then that splits. I want to split them on the empty split on the empty split. So I'm building my data frame of that. If I want to see, I need to look at it here, right? df round n. It's not round on, it's one n. Okay. Okay, what?
The quotes, it's a double quote and a single quote on the split.
Oh, hold on. The quotes should be, let me see here. Just
yeah, I think your code is fine. I think when you say rand n, you say rand n.
Oh,
what does that? Yeah, because
5.
I think
Yeah,
more than the ABCD.
Yeah.
Rand n returns, it will return more.
This is 5 rows, right?
Yes.
And then 1, 2, 3, 4, 5, right?
5 rows, 4 columns. So
yeah,
it should be ABCD, no
E.
Because the columns are your variables, right? So the 4 corresponds to the columns.
Oh no!
I think you're fine.
No.
You're fine.
Yeah, the 4 is for the is for XYZ, the
Right,
index, right? 1 n. Did I import that correctly? 1 n. Let me run it again. Let me see what it's saying here. Shape. Oh, this is 5 by 4. It said this is index 5 by 5 is all right. X, Y, Z. We got 4, 5 here and 4 here. Let me change it to 5. Huh. But this is not 5. I don't have 5 column here. Oh.
4. You have, yeah.
Oh, maybe that empty, I forgot that empty
Exactly.
space.
Yeah, yeah.
That's why the empty space. Now, yeah, that was a problem. So space mean a string in Python, right? So we can do a lot of stuff with this. We can grab whatever we want, right? So let's play a little bit with this. So we can, let's say you want to grab the last row. So you will say df at, let me grab the column first. If I want to grab, let's say, that's probably why. So this, it will return this. If I want to grab more than one column, so I need to put this in the list. So Y, let's say I want to grab column Y and Z. So this will be Z here, right? And let's say I want to grab a, but by the way, this is the same thing. If you are just selecting a columns, right? For example, you have this that Z is the same thing as df at Z. Right, so you just, if you are getting on one of them, you can just say that, right? The same thing, you get the same thing. So now you can now impose a lot of condition here, right? Again, if you try the type of this, you will see that it is a series, right? Because it's just one column. So let me say type, it's a series, right? So type of this is a kind of series. So now let's build some new columns of these, so we can say df new column, for example, let me put in capital, df new, right? Because ABC, X, Y, Z. So I can say that is a df at the column X, for example, plus df at the column, which one I didn't, W, right? I didn't touch W, for example. And then if you look at your df again, you will see that new column there, right? Come at the end. So you can drop that, right? So there is a drop method. If let's say we add this by mistake, we can drop it. So if you want to drop that new, you can say df that drop, and then you tell the name of the column. So that's X new. So we want to drop the new, right? So you gotta set that you want to drop the entire column. So that is axis equal 1. Axis equal 1, you want to drop the entire column. And then you want it to be permanent. Let me do this first. And then we want it here, df again, new reappear, right? So you want it, if you want it to be permanent, then you have to say in place equal true, right? Then when you look at it, new is gone forever. Right. Okay, so you can drop also a row, right? So let's say I want to drop 0, right? I will say df dot drop, and then I will specify the name of the row, which is C. Now, because I'm dropping the row, then I have to say axis equal 0. This will drop the entire zeros. So C is gone. Right? But if I want it again, you will see, because I didn't say in place equal true, so C reappear again. Right. So we can do some more operations. So for example, if I want to return df, I want to grab the place where W, df of W is bigger than 0. So for example, if I run this like this, it will just give me true or false. True where it is true, then false. Now, if I apply df, a data frame to that, it will return the value where this is true, and then it will return NA where this is false. So basically, we only have 2 values. The rest of them will be NA, NA. Only W positive. Okay, so it didn't show the rest of them. Let me look at it. So it only gave me the rows and columns where W is positive. It returned the rows where W is positive. Okay. So now we can impose condition modes to more than one column. Let's say I want W to be So I want this W first of all to be greater than let's say 0, and I can grab only some column. Let's say greater than maybe 1, that might be all of them, or greater than 1.2, for example. If I do that, that would be a restriction. So now, from off that, you can grab whatever column that you want. So let's apply df here. Right, once you apply df, you can grab let's say I want to grab a column X and column Z. So you just column X, column Z. So this should only give me one. Yeah, this is a list of 4 columns. So you gotta put them in square brackets. DF that bigger than 1.2. Let me look at this. Z, small z, it has to be capital. Yeah, right. So only one row, because this is the only place where W is bigger than 1.2, right? So I'm returning X and Z, so these 2 numbers, right? So, well, so now let's move on to multiple index. Let's say you have a data frame, inner index and an outer index. So let me put here multiple index. Right. Okay, let me just put it that way. So let me make this as a markdown cell down here, and then change this cell. Okay, markdown. Right. So for example, we have this list. Right. Let me run them. So my inside index will be this. My outside index will be G's. Right. And then let me build a data frame of these. Right here, I'm zipping the inner and the out. If in fact, let me run this. It will return the pair of inner and outer index, right? So G1, G1, 1, 2, 3, 1, 2, 3. So G's are out there, and then 1, 2, 3 are inner index. So now I want to build a data frame of these, right? So I can say find out a data frame. Let me PD that data frame. Right now, I will fit in these there. So NP, I want to NP the random. I want to build the random numbers, but my index are already set for. So NP the random, the run end. So run end will return a sample that is normally distributed, right? So let's say I want 6 by 2, right? I have to make sure this is 6. 1, 2, 3, 4, 5, 6. Yeah, so that makes sense. 6 rows, 2 columns, so 6 by 2, and then my index. Let me just copy these. Index equal this. So index equal that. And then the columns equal this. I want to give name to the columns. So capital A, for example, capital B, and that should do it. Let me see. Did I give a name to it? No, I gotta say, call it, for example, DF. So DF equal this. And if you want to see it, then we need to look at the data frame. So if you want to grab something inside here, so you gotta consider the outer index and the inner index, right? For example, if I want to grab G's only, right? If I want to grab the G only, so I can use something called LOC. So I will say my df.loc. So we are grabbing by location, and then I will just specify the outer index. We contain the inner index, right? And then that will give me all the G1. Now I can also specify if I want to grab the first row. I gotta be careful here. The first row, the index is 1, not it doesn't start at 0. So if I want to grab the first row, I'll just do this. This will return G1, LOC, right? That LOC, oh, lowercase LOC. So this will return the first row, right? A value is here, and then B value is here. So you remember, if you look at the index, they don't have name, right? We can check that. We can check df that index that name, right? If we run that, you will see they don't have names. So we can give name to them. So we can get the same thing and then set it to whatever name that you want. So I will say this equal the some name. Let's give a name. So the first one can be group, and then the second one can be number. And then once you do that, if you look at your DF again, you will see that the index have name, right? Again, you can do a lot of stuff here. Let's say you want to only grab by level, right? So you can do that. But these are fake data set that I create. I want to get a data that is very similar to real life, and I do some exercise to that. But before that, we need to talk about some operations that you will be doing with data set as a data scientist, like join, merge, and concatenate, right? So let me build some data frame. So I will say this data frame here. So this is what we're going to do. We're going to talk about merging, concatenating, and joining. So that's what we're going to do. So clearly we need more than one data frame. So let's say this data frame, right, is defined as the following, and the index are 0, 1, 2, 3. Right. So if you look at that DF1, right, so you got 4 columns and then 4 rows. Now I want to build a similar data frame to that. So I will say data frame 2. So to be quicker, just copy this and paste. DF2. So you can concatenate these, you can merge them, you can join them. Let me add a third one. So DF3 is equal, I'll just change the same dimension. Okay, so DF3, like that. So with this data frame, like I mentioned, we can concatenate them, right? So if I want to concatenate these 2 or 3 of them, all you need to do is to call pandas, right? So let's say concatenate concats. Right. So we want to concatenate concatenations. So you do PD, you call PD, right? That's concat. And then you call your data frame, so DF1, DF2, DF3. I think that's it, right? So if you don't specify how you are concatenate them, then it will do them by row. So for 1 and then 2 will be below that, and then 3 will be below that, right? Because I didn't specify. This has to be in list. It's a list of data frame. That's why you get this. So once you put in the list, then it should be fine, right? So DF1 is on top, 2 is in the middle, and then 3 is at the bottom. So now if you want them to be joined by columns, then you gotta specify axis equal 1. Right, so let me copy these and then now specify axis equal 1. So I will say here, I want to join these by columns. So axis equal 1. So it will be different. The output will be different. So DF1 got only 4 columns. 4 rows, so the remaining rows will be any, right? So DF2, it has 4 rows, but the index start at the position 4. So anything before that, anything after the index 7 will be any, and so on. Right. So we can also do join. We can join data frame. So let me build another data frame. Right, so let's say we have these 2 data frame, right? And I want to join them. If you look at these 2, let's say left, this, you got two key here, key 1, key 2. If you compare it to right, they have the same key. So we can join these, right? You can join them by and merge them by key. By those keys, they are similar, right? So one way to join these is to write the following code. Right, so you will call pen as always if you want to merge this pen pd that merge. So now you call your data frame, so left, right, how you want to join them. So left, comma right, and then on keys. So these two, so I would say key 1, comma key 2. Right, and that should do it. That set that to any, yeah. So we join them, using these two keys. They have the same key. Let me look at the message. Yeah, Z smaller case. Thank you. So we okay. All right. So most of those questions have been answered already. Now you can also merge, join. This is merge. So let's do join and then go to a particular data set. Copy these. So we want to do merging. No, that's merging. So join. Joining. So again, I have two data sets here, right? I want to join them. Right. So for joining, you can just let me run this. So if you look at left, right? If you look at the right, now I can join them. So if you can say left that join right, right, and then if you don't specify anything, it will just do the join. Now you can say outer. If you say outer join, then it will do the outer join. So after you do left that join right, and then you say how, you got the how parameters, how equal outer, how outer. So they should be different now. So now I am ready to use a real data set. Right, so close to reality. So there is a data set I will be sending to Nana called salary. So we're gonna do some exercise on that. But there are so many things that Panda can do. So it's good to use it with a data that is similar to the reality. So I already import Panda. So what I'm going to do, I'm going to convert the CSV file to a Panda data frame. Right. So again, I would call DF, or you can call it salary. You can give a name. Usually you name your variable so that it will remind you what it is. So you can call it salary DF, right? And that is about salary, right? This is about salary. So I would say is equal PD that read underscore CSV. This is a very important function in pandas. Read underscore CSV. Now I need to specify the name of the CSV file. Salary, I believe that's CSV. So this line right here will convert my CSV file to a Panda data frame. Right. If I want to see, then I need to look at the head of that data set. Right. So give me the first 5 rows of that data set. Right. But if you're repeating this, you have to make sure your data set is in the same location where you open your Jupyter notebook. If it's not, then you have to add the path here, like see, right? Whatever it is, you gotta add the path, otherwise you will not see it, right? For example, if I change this to something that is not in my folder, I'll get this error, right? It's not there, it doesn't know. File not found, error. Right? So that's very important. Your file and your Jupyter notebook should be in the same folder, right? So this returns the first 5 rows of a data frame, the head method, right? So there is a method also called, let me have a lot of empty cell. There is another method called a tail method. So this will return the last 5 rows of your data frame. Right? So as you can see, this data frame content, base pay, job title, employee name, overtimes, and so on. But if you look at the benefit, it has a lot of NAs, right? So as a data scientist, you're working on a data thing. The first thing, it is very important to check for any missing data in your data set. Right. So one way to do that is to run the following. So df that is NA, right? So it's a method. Now, if you want to know the sum of missing data on every row, then you got to add the sum method to it. Right? So this will tell you the base pair missing 609, the benefits is missing a lot, 36,000, and then the notes is missing. So how do I know that this column is missing almost all of them? So if you want to know that, you need to check the dimension of your data frame, right? You remember this is like a matrix. So your df that shape, this will return, it said that you got 148,654 rows, right? So that's exactly how many is missing here, right? How many are missing here, and then how many are, so that means these two columns are useless, right? They will not bring any information, useful information to your analysis. So you can drop those two columns. The ID, if you look at your data frame, the ID is the same thing as the index, right? They are the same. So if you want to keeper, you can, but usually these are the same. So you can drop the ID. The ID will not tell you anything about somebody pay, right? This is just a number, 1, 2, 3, 4, 5, right? So you can drop those useless columns, but look at the benefits. You don't want to drop these, right? Because not all of them are 0. And then this is less than, let me do this, 36,163 divided by 14,8654. If I divide that, it's less than 80%, only 24%, right? So you will not drop these, right? So one way to, handle this situation is to replace the missing one by 0. Some people will replace it by the mean, and then so on, right? So some employee might not have this extra benefit, so it's your call. So we not drop these, but we can replace those NA by 0, for example, right? Base pay here, same thing. It's very tiny, right? So let's see if we can drop those columns. We have a ID, note, and status. So let's drop those. The shape will change. This is a 13 column. So if I do df.drop, and then I have a list of columns. So the first one is ID. Second one is note. After note, statute. Again, I want to drop an entire column. So I would say axis is equal 1, right? So if I do this, and then 1, you see right now, where are they? They are gone, but if I run it again, let me minimize this. Okay, up to agency. They are gone, but if I run it again, you will see, let me make this one head. I want to just take the head so that there's less more space. Head, just 1, right? So now if I run it again, 1, if I run this again, you will see that pop up because I didn't say in place equal true. In place equal true. Right, once you do that, oh, it's not there already. Let me move this because I just deleted it. So let me come here. Okay, so now if I look at it again, a set in place equal true is gone forever, even if I look at it again, right? But if I delete it and then try to delete it again, then I will get error, right? Yeah, the same thing, I try to drop it. These will not exist, so do not run them twice. Then they don't exist, you get error message, right? That's the same thing when you add a column and then you run it again, you run it again, you will add the same column that many times. So I've done that. So we delete those. We can easily check now the shape. So df that shape, you will see that the shape has changed from 13 to that. Now, I said I'm going to replace the NA by 0. So this is how you do that. So df that, right, is NA, fill NA. That's a method, fill NA. And then you got to specify the value. So I would say value equals 0, right? In fact, before I do that, let me run our df that is NA here. That's sum, right? So 1, 2, 3, 4 columns has any. But if I do this, let me copy this. Right. So I do that, and then let me get the head only. I don't want to see this head only one. Now I want to run it again to see if there are any missing data. So if there is any, that sum, you see, oh, in place equal true, right? In place equal true. Here, let me take this out. Right, so now I don't need this off. What did I do? Okay, in place equal true. I'll run it. Now there is no more NA. All the NAs are gone, right? So this is one way to clean this thing. Now, from the previous data frame, we were grabbing specific columns. We can do the same thing here. Let's say I want to grab the base pair, right, of this data frame. I can just do df either that base pair, that will return that, or df at the base pair. So here is a string. Right, so that is if I want to grab only that columns. Right. So now there is a method called columns that will return the name of your columns. Right. So df that columns. So let me. Some people use df that columns, that name or that value, but columns will do the same thing. Right. If you want to know the name of your columns, you run this, then it will return a list of that contain all the columns. Right. So let's say you don't want yes. Okay. So let's say I want to grab only the column that have a numerical values. So I can just say df. So I'm gonna get this list here. For example, I know the one that contain numerical value. For example, no employee name is not there, job title is not there. That so and here an agency. Right. So you apply df to this, it should return only those with numerical data, right? So when I look at this, it seems to me this total pay benefit is the sum of these base pay plus this plus this plus that, right? And is equal to this to me. But you can check that out, right? You can check, you can add those columns, right? So this is the hard way to do it. You can say new. I can create a new df at new. So let's add new is equal df. So what I'm going to do, I'm going to get df at base pair plus df at overtime up plus df at order pay. So order pay. Okay. So let me run this. Let me look at df new. Let me look at the whole data frame that here, for example. So the new should be the last columns. Let me come here. So we can compare it to the total pay benefits. Right. They are the same. Because this will be different from this sometime. We can check that too. But let's work on this new column. Let's say we don't want the position here. Right, is at the end. I want to get it next to total pay benefits. I want to get it next to that, and then so that I will be able to compare them side by side. So again, to do that, you need to get your column. There are many ways to do that, right? So let me do it the easiest way. So you do df.columns again. You get this, and then you would say df is equal this. You reorganize this. So I want this new to be next to this total pay, right? So that once I've done that, then I will be able to compare them side by side, because there are one column between them is not that easy. And so that's one way to do that, right? Once you switch, but you gotta apply the data frame to the columns. It's a list, then we need to apply the data frame to it. So df is equal to df that I reorganize the columns, right? So I move this here, and then if we look at df, that head, I believe they should be next to each other. Total pay and new are next to each other here, right? So you can compare them side by side. Are they the same, right? Let me go to tail. Look at the tail, right? That seems to be the same. So now, let's do it another way, right? So I can go by columns, by hard coding the columns. So let me define a variable called columns. So I'll say calls equal df that columns, right? Df that column. So I want to get it as a list. So list of that, right? Df that columns. Right. So now I want to go by columns. So let's say I want to move this year to next to new, and then you go to the last columns, right? So what I will do, I will say df is equal df, right? So I will grab it by column, so that call. So I will count, right? So I'll start here 0, 1, 2, 3, 4, 5, 6, 7, right? So up to the 7 index, right? So let me remove this. So from 0 up to 7 index, right? So that will be 0, 1, 2, 3, 4, 5, 6, 7, right? So to 7. Now I'm going to add that to the last columns. So that is df, right, at columns. So the last column is -1, right? This df, so these columns at -1, that will return the last one, -1. Negative, the index negative will return the last one. Now plus now the one that is at the index 7. So call, right, at index 7 to 8. So 7 to 8, this will just return a 7th one, right? Let me see, 0, 1, 2, 3, 4, 5, 6, 7. Right. And this will become 8. I'll add this, and then this position will be at the last one. So that's it. How many columns I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. So 1, 2, 3, 4, 5, 6, 7, 8. So up to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then this one go to from 8 to 9. So let's see. Okay. It's it can only concatenate lists, right? This is a list. This is also a list, right? But the only one that is not a list, let me control Z here. The only one that is not a list is this single one here, right? That's a series, so you consider that as a string. So you just put it there. You know, list is between square brackets. I believe that should do it. It's not a string. Okay, so let's run this, and then let's look at the df that head. Right. So yeah, the new is, you know, we move it to the end again, right? Okay, so now I add the columns value earlier here. What is it? yeah, add them like this. You can also add them using the index location iloc, right? So let me show you that. So you can say total. Okay. So I want to create a new thing called total. Total. So I'm adding, right? Let me make this one one so that I'll be able to see the column's name easily. So I'm creating a new columns called total, and then that total, what I'm doing, I'm going to add this base pair overtime order pair benefit right up to here. Right, so from I will be using iloc. The thing is with iloc, it will include the last the start point, the end point. iloc will include the end point, so I have to be careful when I'm slicing. So df.iloc is stands for integer location. iloc. So now I want all the rows. So all the rows mean this. Now my numerical value start at index 2 because this is index 0, index 1. So 2, from 2, 3, 4, 5, 6. Right? So no, this is not part of it. 3, 4, 2, 3, 4, 5. Right? Up to 5. Let me see. So let me look at df head again. If total, I'm taking the sum, right? Sum, right, on the columns. So I will say x is equal 1. I forgot about that. Let's see again. Let me look at it. Let's look at it exactly.
Oh, so iloc stands for integer location. You want to grab them. You see, every time I use iloc, there is a number in there. So we are using integers to get particular rows or columns, right?
Okay. Okay.
Equal to the new, right? So this is one way to do it using the iloc method. Okay. Let me. Right. So again, we can drop these two columns if we want, right? And we can drop any rows that we want, right? So in fact, let's do that because we just add extra. We can drop them. So df.drop. That's df.drop. We have a list of columns. So what's the name? New and total. So new total. Right. So I'm dropping the entire columns. Axis equal 1, in place equal true. Right. So if I look at the head again, that should be gone. Right. So agency is a last thing. Okay.
What does the axis equal to 1
now
signify?
we can what if you
axis equal 1 mean 1 cent for column. That means you want to drop the entire column. Axis equal 0 mean you want to drop the rows.
Okay.
We want to select all the employee name, right? So we can do that using employee name. We can also do that using the integer location, right? We can use that. Okay, so let's say we want to grab the first row using the integer location. How we do that? So you just grab df.iloc 0, df.iloc. Okay, let me see that message. Yeah. Yeah, you can absolutely. Yeah, there have to be a list X. What is it? Oh, you iterated. Yeah, that's fine too. Right. So df. I was going to grab the first row, the iloc. Right. So you just the first row is at index 0. That's it. That should return the employee that is out of the first row, right? Nathaniel. Right. So he will tell you his name, job title, base pay, overtime, other pay benefits, right? And the location, San Francisco. Right. So if I want to grab with iLock, you can grab whatever you want. Let's say on the D, let me look at DF again. DF the head. Right. So maybe this one 2 only. So let's say I want to grab these columns. Right. I want to grab these columns only. So I need to specify if I want all the rows. I think I did already. Let me see. It looks like this. This is rows only. So if I want to grab the entire column, let's say I want to grab the base pay. Right. One way to do it is DF at the base pay. Right. We did that. And then another way is to use intermediate locations, DF the iLock. Right. So now you want all the rows. So comma, and then the columns start at index what? 0, 1, 2, index 2. So 2 to 3. And that's it. That should be base pair. It's the same thing as DF that base pair. Same thing. Right now, let's say we want to print all the employee, right? The name of all the employee. We want to go through all the road and then read the employee name and then return it. So there is a method called ether road. Let me do that here. So we say, so each row, let me write it down, each rows, this will return couples of index and value. So in this case, it will return index and the name. I'm going to look for that, right? So I'm gonna use the method here. So I will say for index, IDX, and name, let me just go by rows. I will say rows, right? In DF, that's ether row S at the end, right? So if you look at def ether row, you will see it's a couples, tuples of Control Z. So for index and row in here, then we want to print them. We want to print the index, IDX. We also want to print the rows, right? Remember, if you look at a row, it has many stuff. If you look at this row, the employee name, job title, base pay, and so on. So we want to grab only the first one. So first one means employee name. That's the first entry. So I will say row at employee name. Employee name. Okay. Right. Run employee name. If I want to grab only the first name, let me run this first. Right. So it give me the full name. So if I want to grab the first name, right? If I want to grab that, then I can see this is the name of everybody that's here. Here you can check the most popular name, the least popular name, check if your name is in there, right? And so on. So if I want to grab only the first part, because this is a list, it's a string, so I'm gonna split it first. So that splits, right? If you look at the first name, last name, there is a just a space between them. So I will say split on the empty space. And then once you split it, give me the first one. So that'll give you the first name of everybody. Right. So first name of everybody. So if you want the last name of everybody, you split it, you turn that. Okay. So let me help this cell here. Cell, current cell. I want to clear the current cell. Okay, it gave me the result already. Okay, there is a text. Can you please take a break? Okay, that's fine. So 15-minute break.
Okay, cool. Yes. Okay, sure. So 15, we have 12:15. So we convene back at 12:11. So let's make it
I think it's 2 p.m. now. John, what do you think? Williams? Do you guys want to keep on going, or we stop here? It's 2 p.m.
So sorry, I think I was muted.
Yeah.
So I was going to, I was saying that yes, let's stop here, and then to all of you, thank you for coming. The recordings are there. I think if you look at the chat area or you check Slack, you see the link to the YouTube videos. So the recordings are there. Again, this was done over 2 weeks. That was 4 days of presentation, and we are only doing this over 2 days. So I will encourage all of you, especially for those of you who don't have the foundational knowledge of Python, go in, take your time, review everything, and then we will see you all again next week for the probability and the statistical concept. That is also will be based on the recordings from the spring, and then William Ampere and myself will lead that discussion. So you can review it ahead of time. We'll come here, we'll play the recordings, and then if you have any questions, as we did here, we'll respond to those questions. Then after next week will be the main live sessions, where that will not be based on recording, that will actually be a live section. So again, thank you all for coming, and then we'll see you all same time next week.
Hi, can we get access to the Jupyter notebook, please?
Yeah, I sent all of them to Nana, so Nana has all of them. I don't know.
Okay, thank you so much.
Yeah, so what you can also do it, if you have any questions, you can post that in Slack, and then someone will go there and then respond to it. And then maybe if you need direction or access to links, you will be pointed out to those links.
Okay, thank you.
You're welcome.
Thank you, everybody.
Otherwise, have a great weekend, and then we'll see you Thursday next week. Thursday next week.
Thank you.
No problem.
All right, bye-bye. I have to jump out for another meeting, so I'm out.
Have a good day, everybody.